All right, let's dive deep into a piece of tech you rely on every single time you drive, but probably never think twice about, the ABS control module. Now, we're not going to look at this as just another car part. No, we're going to deconstruct it for what it really is, a safety-critical computer engineered from the ground up to prevent disaster in a matter of milliseconds. Let's get right into it. So first things first, where does this little brain actually live? Well, you'll usually find it tucked away in the engine bay, physically attached to the hydraulic brake unit. And its fundamental job? It's pretty simple in concept. It watches your wheels, and during a hard stop, it makes sure they don't lock up and send you into a skid. That's what lets you keep steering control when you absolutely need it the most.
To really get what makes this module tick, we have to put on a different hat. We need to look at it from the eyes of a safety engineer. And that means we have to talk about a really important international standard called ISO 26262. This is basically the rulebook for the functional safety of all automotive electronics. Now, this standard uses a risk rating system called ASIL, which stands for Automotive Safety Integrity Level. And ABS modules, they get a rating of ASIL C or even D. We're talking the highest, most critical levels there are. What this means is that a failure isn't just an inconvenience, it's potentially catastrophic. The entire design philosophy starts right there, from that assumption, and it dictates how every single component is built.
Okay, so what is actually inside this high-stakes computer? Let's peel back the cover and take a look at the hardware foundation that's responsible for making these life-or-death decisions. So, inside, the circuit board is a real beehive of activity. You've got a powerful 32-bit microcontroller at its heart, but it's also got custom circuits, memory chips to store things like fault codes, and these heavy-duty transistors called MOSFETs. Think of those as the super-fast digital switches that actually control the physical brake hardware. Let's just zoom in on a couple of the key players here.
You can almost think of the module as having two brains that work in tandem. The MCU, the microcontroller, that's the master strategist. It's doing all the heavy lifting, calculating complex stuff like vehicle dynamics. Then you have the ASIC, that's the specialist, a coprocessor that's built to handle all the boring, repetitive, low-level jobs really efficiently. This frees up the main MCU to focus on the big picture.
And then there's this thing, the watchdog timer. This is brilliant. Think of it as a dead man's switch for the processor. The processor has to constantly send a little "I'm okay" signal to this completely independent timer. If that signal ever stops, maybe the software froze or it's stuck in a loop, the watchdog forces a complete system reset. It's a non-negotiable safety feature that makes sure the system can never get stuck in a dangerous, unresponsive state.
So we've got the hardware, but how does the module actually know what the car is doing at any given moment? Well, it all comes down to how it processes signals from the wheels and how it talks to the rest of the vehicle. This formula right here, this is the secret sauce, the slip ratio. The module is calculating this constantly for every single wheel. It's just comparing how fast a wheel is turning versus how fast the car is actually going. When that slip value gets too high, meaning the wheel is slowing down way faster than the car is, it knows a lockup is about to happen, and that's its cue to jump in and take action.
You know, the ABS module doesn't just work by itself in a vacuum. It's a key citizen on the car's internal computer network, which we call the CAN bus. It's constantly broadcasting information like wheel speeds and its own status, while at the same time listening for crucial data from other modules, like what the steering angle is or what the throttle is doing. This network is what allows it to make smarter, more holistic decisions.
And when that chatter stops, you get a really serious trouble code, U0121. This means the module has just gone completely radio silent on the network. And that is a huge red flag because it tells every other computer in the car that a major safety system has just gone offline. That's why you'll see a whole Christmas tree of warning lights pop up on the dash all at once. Okay, so we've got the data, we've got the logic. But how does this digital brain actually command real-world physical force? Let's connect the dots and see how its calculations translate into actual stopping power at the wheels. So the module itself, the electronic control unit you see here, that's the commander-in-chief. It sends these incredibly precise electrical pulses to the hydraulic unit, which is the muscle. And that unit is full of solenoid valves and a pump motor that directly controlled the brake fluid pressure. And it all happens in this lightning-fast three-step dance. First, it isolates the brake caliper to hold the pressure steady. Then, it dumps the pressure to let the wheel spin back up just a tiny bit. And finally, it rebuilds the pressure. This little cycle happens up to 15 times every single second. That's what you feel as that pulsing in the brake pedal when the ABS kicks in.
Right. So knowing all of this intricate detail, how do we actually apply this engineering-level knowledge to the real world of troubleshooting and repair when things inevitably go wrong? Look, these modules live in a really nasty environment, and failures almost always come down to one of four main enemies. You've got thermal cycling, that constant heating up and cooling down, which causes tiny, microscopic cracks in solder joints. You've got water getting past the seals, which leads to deadly corrosion. Voltage spikes, maybe from a bad jump start, can absolutely fry the sensitive electronics. And finally, just years and years of constant vibration can literally shake things loose. The most critical input to the entire system is the wheel speed sensor signal. So a professional diagnosis always starts here, with an oscilloscope. And you're not just looking for a signal, you need to see a clean, perfect, predictable waveform. If that signal is choppy or missing, it's pointing you towards a bad sensor or a wiring problem, maybe even a damaged tone ring on the axle, not necessarily a bad module. Oh, here's a fantastic pro tip, especially for those really tricky intermittent faults. If you have a module that works perfectly fine when the car is cold, but starts failing once the engine bay heats up, that just screams cracked solder joint. So a quick blast of freeze spray right on the warm module can cool it down just enough to make that connection solid again. If the problem instantly vanishes, well, you've just found your culprit. And for anyone who's brave enough to attempt a component-level repair on one of these boards, safety and precision are everything. The absolute first, most critical step is to always discharge the large capacitors on the board. They can hold a nasty charge. After that, it's all about meticulous inspection under a microscope and using the right specialized tools like a hot air station for any delicate rework. And here's just a dose of modern reality for you. On most cars built after, say, 2010, you can't just swap in a new module and call it a day. The replacement part has to be electronically introduced to the car. That means coding it with the vehicle's VIN and its specific configuration, like tire size and so on. If you skip this step, it just plain won't work right. And you know, in EVs and hybrids, the ABS module's job gets even more complicated. It basically becomes an orchestra conductor for the entire braking system. It has to perfectly and seamlessly blend the slowing force from the electric motor, that's your regenerative braking, with the pressure from the old-school hydraulic brakes. It's an incredibly sophisticated balancing act, and it happens in milliseconds. Which brings us to a final, pretty interesting question to think about. The ABS module was fundamentally designed to assist a human driver. But as we move toward fully autonomous cars, how does its basic logic have to change when it becomes the primary decision maker, with no human foot on the pedal as a backup? That's a huge challenge that safety engineers are working on right now.